So in this lesson, what we're going to look at is we're going to move from knowing what a solid and a liquid gas is to understanding what happens whenever you heat or cool down a solid, liquid, or a gas. Now, to start off, let's see what you can remember. We've got 3 of these. In each one, we have got a few thought bubbles. And on each of these slides, I want you to see whether or not you can tell which of these are true. So these are all statements about solids. If you pause the video, give yourself some time to identify which ones are true. And then whenever you start the video up again, the answers will be revealed. So if you pause the video now, and what you can see is the ones that are true are C, D, and F. A solid always takes up the same space, it keeps its volume. If you leave a solid, it will keep its shape. Some solids are hard, some solids are soft. That's true. The ones that were incorrect, solids can flow. That is incorrect because their particles can only vibrate. You can't see through a solid. Well, some solids you can't see through, like you're a solid, but some solids you can see through, for example, windows. And solids are hard. Well, we know not all solids are hard. A banana is a solid, but it's very easy, very soft to cut through. So this slide is the same format. We have 6 statements about liquids, and you have to work out which ones are correct and which ones are not correct. So if you would like to pause the video and have a go at working those out for yourself. So if you pause the video now. And hopefully you've now had time to work out which ones you think were correct. The ones which are correct were B, C, D, and F. So a liquid keeps its volume. Liquids spread out to fill the containers they are in. Liquids can change shape, and a liquid takes the shape of the container. And F, liquids flow. The other 2, liquids are clear, and light can pass through all liquids. So what I'd like you to think about is milk is a liquid, and milk is definitely not clear, and light doesn't pass through it. So a lot of the times when people think about liquids, they immediately think of water, but there are lots of other liquids. So for example, milk is a liquid, lava is a liquid, and they are definitely not clear. Now this slide is the final one of these. It is all statements about gases. There's 7 this time. And as before, identify which ones you think are true. And if you pause the video now. So I'm hoping you have had time now to identify which ones you think are correct. The ones that are correct are D and E. So a gas doesn't have a fixed volume, it spreads as far as it can, and gases can flow. Now the other statements, some of them can sometimes be true. So gases are colourless. Now air is the main gas that we're aware of, and it is colourless. However, smoke is also a gas, and we can't see through it. Gases definitely don't keep the same shape. They move to fill whatever shape they can. Again, you can see through a gas. That is true for a lot of gases, but again, smoke is a gas that you cannot see through. Gas always takes up the same amount of space. Well, that's not true. We know from last time that you can squeeze a gas in a balloon so it takes up different space. And gases can't flow. Well, that is incorrect, because if gases couldn't flow, we wouldn't have things like drafts or wind. So gases can definitely flow. Now an overview, just a review of what we learnt last time. We've got pictures representing a solid, a liquid, and a gas. When we look at the particles, we can see that the particles in a solid are very close. The particles in a liquid are close. There's still some of them touching one another, but in a gas, the particles are very far apart. In terms of does it flow, a solid doesn't flow, a liquid can flow, and a gas can flow. In terms of is it able to change shape, a solid is not, a liquid is, and a gas is. And finally, can it change volume? Well, a solid cannot change its volume, a liquid cannot change its volume, and a gas can change its volume. So by far, the gas is the one that has the most freedom. It can flow, change shape, and change volume. Now, what we're going to be looking at in this lesson and the next lesson is understanding some experiments that can help us understand how the different states of matter work and leading towards understanding how we can change one state of matter into another one. But today we're just going to focus on what happens when we start to heat up solids and liquids or when we start to cool them down. And these are the success criteria. I'm just going to give you time to read those. Specifically today, what we will be looking at is understanding if you give atoms more energy, you can change them, and understanding that if you cool atoms, you're reducing their energy. Okay, so what we have is an experiment. Now, if you're in class, you might have the opportunity to do this experiment in class. However, if you are at home watching this is an experiment. If you have a balloon and you have a measuring tape, you can try, but also you might be able to tell just by looking at the balloon without the measuring tape. You might be able to see what happens. So what we'd be looking for is taking a balloon and blowing it up. So you're filling it with air, and then you're measuring how wide it is. At the widest part, put a measuring tape the whole way around it. Then put it into a fridge or freezer. If you're doing it in class, we can only do it for 30 minutes. If you're doing it at home, you can try and do it for a couple of hours, or you could even do it overnight, would be even better to see what happens. And what you're doing after that time is you're going to measure the widest part of the balloon again, and you're going to see, has it stayed the same? Has it got bigger? Has it got smaller? Then there's another experiment. Again, if you're in class, you might get the opportunity to do this, but if you're at home, you can do a modified version of this experiment. So if you are in class and we're doing it as an experiment together, what we'll be doing is we'll be looking at a beaker and we'll be heating it over a Bunsen burner and seeing what happens to the height of the water as we heat it up. Does it stay the same? Does it go down, or does it go up? If you're at home, you can modify this experiment in that if you've got a measuring jug or you've got a big glass, what you can do is fill that glass about halfway and just remember where you filled it. Then pour the water into an empty kettle and boil it, and then pour it back into the container and see whether or not it comes to the same height or whether it has changed height. Or you can actually, on a cooker, if you've got a pot or a pan, you can try, but it's easier to do it with boiling water in a kettle and then pouring it back into a container. Obviously, if you're working with a kettle, it's really, really, really hot. So if you are pouring it into a glass, make sure you're really careful and obviously wait until it's cooled down before you try and get rid of it. So if you want to try those experiments, what I suggest is that you actually skip on because the results are going to be shown. So maybe if you want to try those experiments at home, you pause the video and come back after you've had a go. If you're not able to have a go, or you've already had a go at the experiments yourself and you're coming back to this video, I'm going to show you some results from whenever I did this. So in my experiments, I was cooling down a balloon and I was heating up some water. Looking at the balloon first. So I had a 36 centimeter was the widest part of my balloon when I started. At the end, now I only did it for about an hour in a fridge, and it went down to 29 centimeters. So it got smaller. When I did my heating water, it started out at 50 centimeters cubed, and I heated it. I didn't boil it, I took it to 80 degrees, and it went up to about 55 centimeters cubed. So it got bigger. Now, from this, I can conclude that when I cooled something down, it got smaller. When I heated something up, it got bigger. And so that is a general rule. When you heat up matter, it gets bigger. And the scientific word that we would use to describe getting bigger is expanding. So if you can try and use the word expanding whenever you mean getting bigger, that will be really good. And we also noticed that when we cool something down, it got smaller. And the scientific word for getting smaller is contract or contracting. So if you can try and learn and use the words expand and contract, that would be really useful and very scientific. Now, what we're going to look at is why that happens. Now, when you heat up particles, what you're doing is you're giving them more energy. Now, whenever you have more energy, if you're a solid, the particles can only vibrate. If they get more energy, what happens is that they vibrate even quicker. So they move more to the left, more to the right than before, and they start to hit into the particles beside them a lot and start pushing them away from one another. And as you keep heating and heating and heating, they get further and further away because they are vibrating more. And so you can see in that diagram that the particles end up further apart. And as a consequence, as a result, the solid expands. In a liquid and a gas, where the particles are able to move, the reason they expand is because they're just able to move further than they were before. So a gas, as you heat it up, the particles have more energy, can move even further. In a liquid, the particles do a combination. They can move further away from one another and they expand. Now, when we cool something down, we're taking away energy from the particles. So they're able to move less. So if they're a solid, they're able to vibrate even less. And what that does is that means that they can't push each other away anymore and they're forced to get closer together. And as a consequence, if the particles are getting closer together, the material gets smaller or contracts. Now, overall, for a liquid and a gas, if they have less energy, if the particles have less energy, they're not able to move as far away from one another as they were before, and they get smaller. So in summary, what we looked at today was when we heat things up, we give particles energy and it makes materials expand. If we cool things down, we take energy away from particles and it makes materials contract. So that was looking at heating and cooling materials. Next lesson, we'll look at what happens if you keep heating a material even more after it's expanded and cool it down more after it's contracted. So I'll see you next time. Bye.